Let's take a look at the difference of two squares. How do we factor difference of two squares? A squared minus b squared factors into a plus b times a minus b. So basically what you're doing is you're taking the square root out of a and out of b, and then you have the same binomial terms except for the sign in the middle. So let's take a look at an example. X squared minus 36. Make sure this is a difference of two squares, and also make sure it doesn't have a greatest common factor. It is a difference of two squares. It doesn't have a greatest common factor, so let's go for it. We have an x squared first, so I can factor this x squared into x and x in the second binomial. What is the square root of 36? Well, it's 6. So plus 6 minus 6. Now which order you do that doesn't really matter. You could write the minus first and then the plus. That makes no difference. Here you go. You just factored your first difference of squares. How about another one? Let's take a look at 2a squared minus 162. Now, remember what I said a minute ago? You have to check and see if there is a greatest common factor. So in this case, we do have a greatest common factor. And what is this greatest common factor? You can answer it for yourself. The greatest common factor is 2. Now what we're doing is we're dividing 2 into 2a squared. You can either, oops, this pen isn't working right. You can either divide by 2 mentally, or you can actually write it like this. And what's left is a squared minus 162 divided by 2 is 81. Look at the parentheses. The parentheses is another difference of squares. So make your two parentheses, factor the a squared into a and a over here. What is the square root of 81? 9. Good. Plus 9 minus 9. Guess what? Done you are. You just factored a binomial that had a GCF. Let's do one more. How about x squared plus 4? What's the difference here? Oh, difference. Difference has a minus. This one has a plus. The sum of two squares cannot be factored unless they have a greatest common factor. Here we do not have a greatest common factor, so if this sum of two squares does not have a greatest common factor, it cannot be factored, and that is called prime. I'm just going to write now. Prime. It cannot be factored, it is prime. Let me give you another one. Basically same concept, 2x squared plus 25. Again, we do not have a GCF here, so in this case we have another prime situation, prime factor. Let's take a look at an exception to the rule. We have a sum of two squares here. Now prior I said this could not be factored. However, we always have to check, do we have a greatest common factor? Now this binomial does have a greatest common factor, and this greatest common factor in this case is 4. 4 is the greatest common factor. If you divide 4 into 4x squared, you're left with x squared plus 4 into 16 is 4. Always check the parentheses. Can this be factored further? No. In the parentheses, you have a sum of two squares that cannot be factored further. So guess what? You are done. That is the factorization of 4x squared plus 16.